Hello friends and welcome to another lecture on chemical engineering thermodynamics. Today we'll be taking up an interesting problem. Now this problem is on your screen and it might appear a bit big, but then it can be solved quickly. This problem has come in Mumbai University December 19th. It's question number 4B and it's for 10 marks. Find the volume of N-pentane at 500 Kelvin and 20 bar for a gas which obeys Redlich Kwong Soave equation of state. Redlich Kwong Soave equation of state is given by, the equation is given, and where A and B is given to you, the formula for A and B is given. The formula for alpha is also given to you. The formula for S is given to you, where this W, which appears as W, is actually omega. And then you have the critical temperature and the critical pressure of N-pentane given to you along with omega. Sorry. Now, how do you solve this problem? The first line of attack is to calculate S, because S depends on omega. So, let's calculate the value of S. Now, let's use our favorite calculator for it. So, that's 0.48508 plus 1.55171 into 0.251, that's omega, minus 0.15613 into 0.251, that's square of omega, and we get the value of S. Now the value of S is 0.8647, 0.8647. So we make a note of it. Now further we calculate out what is the reduced temperature, because we want to calculate alpha for it. Now the reduced temperature is going to be the temperature at which you want to do the calculation, that is 500 Kelvin divided by the critical temperature, which is 469.9 Kelvin. So the reduced temperature is now going to be 500 divided by 469.9, and that's 1.064. 1.064. Now, mind you, this does not have any units, so we make a note of it, 1.064. Further, we proceed to calculate alpha, which is nothing but 1 plus S, that is 0.8647, multiplied by 1 minus the square root of reduced temperature, which is 1.064, the whole square. Now, as it is, we use our trusted calculator to do this numerical donkey work. So we start our bracket, and it's 1 plus 0.8647 multiplied by, start the bracket once again, 1 minus square root of 1.064, end the bracket, and square it up. Let's delete it off. Yes, so we need to come out of this. There was a slight mistake here. We need to come out of the square root. So we put the bracket here now. This is the bracket out of the square root, and this is the second bracket out of the square root, and we square it. And let's check. Okay, there was a square root inside this, so we'll have to delete this off. That's it. Now is equal to, that's alpha is equal to 0.9462. 0.9462. That is the value of alpha. So this is where we start our real calculations from. Now we have A, we have to calculate the value of A, we have the value of alpha. Now we need to only calculate A and B. Now, mind you, the value of R, choosing the value of R is very important here. When we choose the value of R, we usually choose that 8.614 kilojoule per kmol Kelvin. That's right, 8.614. So that's not 8.614, 8.314. That's right, 8.314 kilojoule per kmol Kelvin. Now we need to understand here that the pressure will be here in kilopascals. The volume would be in meter cube, and the mass will be in kilomoles, and the temperature will be in Kelvin. So it's very important to understand this. So first of all, we need to understand that the pressure that we need to take, which is given as 33.7 bar, we will have to convert it into kilopascal. So 33.7 bars is going to be 33.7 into 100 kilopascals. That's going to be equal to 3370 kilopascals. Now that's our critical pressure. Now our critical temperature is equal to, let's make a note of it once again, 469.9. 469.9 Kelvin. Now let's proceed with calculating A, which is given as 0.42748 R squared TC squared by BC squared. So our trusty calculator comes out 0.42748 into R square is 8.314 square into TC square, that is 469.9 the whole square. That's it, the whole square, divide by PC, that is 3390 the whole square, and we get it as 0.5677. Now we get the value of this as 0.5677. Now we calculate the value of B. So the value of B is going to be equal to, trusty calculator out, 0.08664 multiplied by 8.314 into 469.9 divided by 3370, and that's equal to 0.1. So that's 0.1. Now we made a slight error here. While doing the calculation, we took the value of PC as 3390. So let's recalculate it once again. A quick recalculation for the value of A. Let's do it. 0.42748 into R square, that is 8.314 the whole square, into 469.9 the whole square divided by 3370 the whole square, and that's 0.5744. Not much of a difference, but still let's make a note of it. 0.5745. So that's 0.5745. Now we have the value of A and B, and let us quickly write the equation. Don't bother simplifying it. I will tell you an easier method to solve it off. So our pressure is 3370 is equal to 8.314 into the temperature is 500 Kelvin, and the volume is of course V minus B. So that's V minus B, that is 0.1, minus A, that is 0.5745 into alpha, which is 0.9462, 0.9462, that's a decimal here. And then we have V plus B on the denominator. So that is V plus 0.1. Now, whenever you get such equations, don't ever try to simplify it and solve it on the calculator. Use the power of the calculator to use it. I know you can make a cubic equation out of this and give the cubic equation to the calculator. But I'll tell you a better method. So use the power of the solver of the calculator itself. So 3370 alpha, and then afterwards you have is equal to, then afterwards the first number, that is 8.314 into 500, now divided by alpha x minus 0.1. That's going to be minus of, after that, this 0.5745 into 0.9462 divided by alpha x, start the bracket, alpha x plus 0.1 and close the bracket. There we have the equation. Now we press shift and we press solve and we press is equal to. Now it starts solving. Now we get a value of 1.334. So we get a value of volume as 1.3334. Now this value is going to be in terms of meter cube per kilo mole. Right? Now, how do we check whether the answer is right or wrong? So, just a moment here, guys. Yes. So, the value should be close to the ideal gas. Not exactly, but close to be. It should be close to be the ideal gas volume. So, we take it as the ideal gas volume is nothing but 8.314 into 500 divided by the pressure, that is 3370. Now we do a calculation for that. So that's 8.314 into 500 divided by 3370, and that's equal to 1.232335. So that's 1.2335. That's 1.2335 meter cube per K mole. Now remember one thing, it's close to this. So this is the right value. Now what happens is when you solve such equations, you get multiple solutions when you solve such a cubic equation. Now there could be two answers here. Whenever we solve a cubic equation, if you solve this as a cubic equation, you will get three values of volume. Now the highest volume is your answer, because that is the volume of the vapor. The least volume is liquid volume. Now, that is an answer you're not supposed to use or calculate using this equation, because these equations do not predict liquid volumes very accurately. And then you have one answer in between them. But if you really solve it for a state in which the fluid only remains as a vapor, you will get one real volume and two complex volumes. When you solve it the way you have solved it in the calculator, we solved it, you would get most probably the highest volume and the one which is real. Now that's the answer which you're actually looking for. So this is the shortcut way of doing things quickly. Fine guys, that was all about how to solve this problem. Hope you have enjoyed this video and you would be looking in for more such videos where an explanation is given into how to solve the problems quickly and get the marks. Of course, marks are very important. They play a very important role in the career. Higher the marks, greater are the chances of getting a good job. And of course, my videos are not directed towards getting marks, but it's directed towards ensuring that each and every student learns the correct way the thermodynamics needs to be learned. So like and subscribe my videos, and do write in your comments what are the problems you actually need to get solved. Now you may be from some different university, you may be from Karnataka University, you may be from university in Tamil Nadu, or you may be from a university in the north, or you may be from a university in Rajasthan. Just send me over the question paper. I will put the solutions which you want. I am here to help you, but of course you need to like and subscribe my channel to really see that I help you out, and you have to tell your friends, popularize it so that I get more number of views and more number of subscriptions, and this makes this entire enterprise of making videos for you worthwhile. Okay friends, have a great time. It's Corona times. Take care. Goodbye.